Okay, so in this lab we'll be looking at OSPF Single Area Routing. Now, for those of you who don't know what OSPF is, it simply means open shortest path first, and it's a type of dynamic routing. Now, it means the router will learn about each other's network and then share information. So, when a packet is moving through the network, it won't use just one path. It can use multiple paths depending on the situation, right? Now, this is mostly used to provide redundancy. Yeah, if one router is down, you can use the other path. So, I'll put a link in the description so that you can have this PDF you can use to perform the labs on your own. Now, this lab will probably be 60 minutes max. Yeah. So, in the PDF, you can also take a look at the key terms that will be used here. You can learn that on your own. There's also the topology. So, with the topology, I'm going to use four routers and then have them all in the OSPF, right? So, let's take a look at the IP addressing. That will also be in the description. So, you can pause and have a look at the IP addressing will be easy. So give you a few minutes. Now you can just pause it. So let's start with the configuration. I have Packet Tracer here. So I'll start by putting the routers there. We have one, two, three, four. I'm rename them. Router one, two, three, and four. Right? Now that we are done with that, we start with the connections. We are going to use serial DC. Now, uh, in Packet Tracer, they usually use a serial DC cable to indicate that it's a wide area network to show that these routers are not close to each other but over a few meters, which the normal Ethernet cable. I mean, the Ethernet cable can go like 100 meters before the signal starts to attenuate. But with the DC, that can go greater distance. But in the real world, they use fiber right now. Some still use, but fiber is more used. So I just start by putting a serial DC interface in. Just switch it off, then have it on. Do the same for all the routers. You have to switch it off before you put it in. Otherwise, so yes, let's try this one. It's easy. It'll tell you blah blah blah. You have to turn it off, turn it off, turn it back on, switch it on. The same for router 4. Switch it back on. Right now, we can start with the connections. Serial DC. This one, the one with the clock on it. pick 0. This one go to 1. I mean router 2. Put it here. Yep, I think we are done. Exit. Yeah, I think this is okay. It's okay. So we start with the configuration. And one thing you need to know is uh, routers have their interfaces turned off by default, and we'll have to assign an IP address to the interface. A router is not like a switch. Routers are different. So starting with router one, we're going to start with new conf t. Let's just rename it. Rename R1. Okay, so we are going into the gig interface 00 because that one will connect to the PC. So we want to configure that one right now. Now we are in IP address, IP address. From the IP addressing table that I showed you earlier, let me bring it back again so that you know what I'm talking about. You see that in router one, the gig 0 interface, IP address 192.168.1.1, subnet mask 255.255.255.0. That's the gate interface connecting to PC1. So IP address 192.168.1.1, 255.255.255.0. I've done with that. Now we turn the interface on. I already said by default routers have their interfaces off. We turn it on. You don't turn it on, you have to go through a whole lot of troubleshooting. No shutdown. Now you have it. Change link state is up. So I'll exit right here, then let me save it. Do right. Okay, so we are done with the interface connecting to the PC. So do same for the serial interfaces. The serial interfaces. So I'll start with interface serial 00 IP address. I remember if you're wondering about the IP address, you can look at the IP address table that I provided. 10.0.0.1, 255.255.255.252. For router 1, we set clock rate 6400. Again, we turn the interface on. No shutdown. It's back on. We exit. do right. Now, rather than we completed that for the serial interface 000/0/0 like three zeros, two slashes. Now let's move on to the next serial interface. That's two zeros and a one, 0/0. What am I? 0/0/1. Yes, that's the next serial interface. So int SE 0/0/1. Yeah, this one. Then with that interface, we use the same procedure we did for the serial interface. IP address, its IP address being 10.0.1.1. Again, you can refer to the IP addressing table over here. Here's okay, with the IP addressing table over here. So let me continue 255.255.255.252 clock rate. Oh, I didn't complete it. Clock rate 6. I have no clock rate. Okay. Oh god, what the fuck you mean I'm no clock rate? Oh, oh my god. Let me see. It's rather 64,000. So I messed up with the first one. We'll go into that interface and then change the clock rate again. Then the clock rate was not set for it. So now that we fix the clock rate for the second interface, let me continue with the process. No shutdown. Didn't even see or something wrong there. Shutdown. Exit to right. Okay, so we go back to the this interface and then fix the error because it's not that interface. 0, then clock rate. Okay, so we done. Uh, do right. We've saved it. Let me exit and see if it took effect. Okay, so yeah, you can see now. Let's move on to router 2. Nope. Again, we start renaming. Then repeat the whole process again. But we router 2, the whole process, but not the same IP address. So I hope you get me. So we start with the interface connecting that will be connecting to the PC 0/0. Then we give it an IP address. IP address of 192.168.2.1. Then we go 255.255.255.0. Okay, so as we are done, again, no shutdown. Exit. Do right. Saved it. So we move to the serial interfaces. Int se 0/0/0. We set an IP address for it. IP address 10.0.0.2. Again, you can refer to the IP addressing table that I left. 55.255.255.252. Let me see if we need clock width for this interface. Nope, we don't need it. So over here, we don't configure clock width, we just move on. Again, we turn it on, we shut down. Move on to the second serial interface. Int se 0/0/1. IP address 10.0.2.1. 245.245.245.252. Again, I almost sound like a broken recorder. We have to turn the interface on. We have to turn the interface on. I think I'll be done. I wouldn't say that anymore because it's probably ringing in your head right now. Turn the interface on. Turn the interface on. Easy to do, right? So we are done with router 2. We're done with router 2. So move on to router 3. Same procedure again. Host name. Wait, sorry that. T host name R3. Host name R3. And we start with the configuration. You have to repeat the whole process again. Yeah, what if no, that would be for another video. X0 IP address EFS 192.168.3.1 255.255.255.0. Shut. We enter the serial interface. IP address 10.0.1.2.255.255.255.252. shut down, exit to right. It has been saved. Move on to the next serial interface. Down router 3, we want to run this same procedure. About choosing G's. We start same boring procedure. Int G0/0 IP address 192.168.401.245.245.245.0. Shut down. Exit. Do right. Button to save. Now we enter first serial interface. IP address. What would it be? What would it be? 10.0.2.2 255.245.245.252. Again, I'm not just guessing these IP addresses. You can have a look at the IP addressing table that we used. Wait, I'm have a look again. You're doing router 4. Looking at router 3. We're done with the first interface, the serial interface. Mm, Move on to the second interface. IP address 10.0.3.2 255.255.255. We're almost done with this boring one. We are done. We are done. We are done with the serial interfaces. As maybe we are done with the whole work. Now let's add the PCs. Yeah, first let me check. Let me check. Okay, we got it. Got it. Got it. And we got that one too. So I'm going to use a straight through. Connect it to the interface that we configured it to. Right? Put it in anything and you're going to mess the whole thing up. Unless maybe you chose a different interface, then you put it to the interface you configured. Maybe you used one, but for me, I use zero, so I'll just put it in zero. I mean, I made all of them to be zero so that I wouldn't have any problems with it. Let me rename them again. Well done. Now, the PCs themselves, they also need an IP address. Right, that's over here. The PCs themselves need an IP address and a default gateway. Where did it go? Oh, yeah. So we start with PC1. 192.168.1.10. The default gateway will be 192.168.1.1. Go to PC2. Again, these IP addresses are not random. I just don't uh, input any random number that comes in my head. These are carefully planned numbers. So it's 3 to 168.3.10. Like 168.3.1. Then last one, 192.168.4.0. The default gauge of 192.168.4.1. Good. So we're done with the PCs. I wonder what will happen if I pin PC2. Should I? Let's try. Header flag. EC2 is 192.168.2.10. Hmm. Destination post unreachable. Well, let's continue let's continue by activating OSPF on the routers. So we start enable conft router OSPF 1 router ID 1.1.1.1 network 1. You have to be very careful over here. If you mess things up, you go through the pain of troubleshooting. I know probably some of you may say you like troubleshooting, but I don't. I take time with the configuration to mess things up so that it wouldn't be a pain the next time. So this one is for the interface connecting to the PC. Then later we'll move to the serial interfaces as well. 0.0. I think they call this one wildcard or something. Yeah, the zero. It's almost opposite to the subnet wildcard. Is it wild? Yeah, wildcard. Then area 0. Then I just move on to the serial interfaces side. Let me stretch a bit more. So with that 10.0.0.0 0.0.0.3. So we done with router 1, the right. Let's go to router 2. Same procedure again. So we could have copied it. I don't know, but let's just continue. Forgot the one. Okay, now it's been added. So we continue. Router ID 2.2.2.2. Start network 192.168.2.0.2 area 0. Check. stretch this one bit. Now what the fuck happened? God, this is super boring. Let me check something from router one. Let's router one. And compare it to router two. You know what? We good. We good. Whatever comes, we just troubleshoot it. So router three, the router ID will be three. I can see why I didn't like recording long videos. Well, with this one, I can't break it into several parts. It just has to be one long video. And then two, 168, 2, I just hope maybe I press record. I just hope it's about to make a mistake. 192.168.3.0 0.0.0.255 0 network 10.0.1.0 0.0.0.3 0. Move on to the next. Oh man, just messed it up. I mean, I hope you are just following it. So then, or I mean, if you're following, you wouldn't find any problem with it. Now let me just clean it before someone's like, Okay, then I forgot to tell you. I think after the whole thing, then we will check for the OSPF neighbors and stuff. Yeah, let's do that. After the whole thing, then just open it up and check for the neighbors. So we are working on router 4. All we are doing is we're just activating the OSPF, telling it which networks. 10.0.0.0, 0.0.0.2. And just wait for that guy so you don't come and mess it up again. There he is. Then 10.0.3.0.0.0. Sorry, we are 0. Oh, we are done. Shit. Okay, so thing for us to check the neighbors have to be like exit and then show IP. We're supposed to get two neighbors. If we check on router 4, we must get two neighbors on it. OSPF NIGHBUR. So you can see two neighbors with their ID 2 and 3, right? So which means this neighbor here is router 3. We made it. I could share my screen. It's too big. But anyway, this is router 4 over here. And you can see router 4 has two neighbors over here. And the two neighbors, their IDs are 333 and 22. That's what made it. So it means it's router 3 and then router 2. And it's even assigned with the interfaces over here. So if we do same for all the routers, we get to know who their neighbors are, right? So let's do same for the routers. Exit, show IP. This we are checking for router 2. You're going to see 444 111. Forgot IP OSPF. Told you, right? Now let's go for router 1. I mean, this is also a way for you to like verify if like you're on track, right? Show IP OSPF NIGHBUR. You see that? Perfect. I'm pretty sure you just let's just do it in case. What do I mean in case? I configure it myself. So um show IPOSPF. Right. Everything is done, but let's check. We can use it to see if everything is okay. Okay, so it's now working. Which PC was this? I think this was PC2. So we can ping PC2 from PC1. But pinging is not what we are here for, right? So let us enter the simulation mode. I could reset all this. I think ping is like ICMP packet. Ping is ICMP packet. We can erase them or then leave ping there. But let's just leave it there. So let us try ping, like ping, repeating the same process again, right? So we can watch how things will unfold here. We are pinging this PC. We want to know which route is going. Obviously, it's going to take the shortest route. It's going to take the shortest route. Let's just watch. Remember, routers are not switches that they just broadcast. They know where you are. They will learn where you are before they do any sending. They don't just flood blindly, right? So the packet was received. I mean, it's going to do this like 4 times. So that was just the first one it just did, just going back and forth. This is showing you in real time what really happens, but not uh I mean it happens in milliseconds, right? You can see here this it uses is it micro or milli? I think it's microseconds, 6 microseconds. So it's going to go back and forth those 4 times. But since we have activated the simulation, we are going to see it step by step. You're not going to see it shum shum. You're going to see step by step. See, it went back and forth. It's now with the second one. Now let's wait for it to um, be done. You know what? Let's pick router 4 since it let's pick PC4 since PC4 is much further than PC2. Yeah, PC4 is much further than PC2. Then we can know which route it took. Reset simulation. So PC4 was 192.168.4.10. So we start paying 192.168.4.10. 4.10. Then let's watch it unfold. Where will it go? See, so it took um that route. It moved from router one to router two, then to router four before it got to PC4. So let us take note of the path he used. He moved from here, 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 and here. That's what he did. Uh, if I could change the time for simulation. Okay, so we saw the path it took. That's basically OSPF. It's taking the shortest path. Like it always wants the easy route. But let us assume it takes this path. It usually takes um, the router two's path. What happens to router 2? It will obviously take router 3's path. But what happens if both router 2 and router 3 are down? There isn't any direct link between router 3 and router 4. So that means the packet can't get there. That means the system is not fully redundant, right? So you can pause the video, then try and um, create a link between router 4 and router 1 at the same time for router 2 and router 3. I think because we used 4 routers, I mean it's even. There is no need for it. Even if it takes this part or it takes this part, it's the same distance, same equal distance is taking. That's why we are seeing it moving from router 1 to router 3. It's not a static route. Again, OSPF is not a static route, it's a dynamic route. It's going to change if it needs to. But this system is not fully redundant. So we are going to configure again, adding new serial interfaces. So we begin. Let me stop this one. Just real world. Now let me switch this interface off, and then we will try what I was saying. Let's just switch it off. Stand off. So uh, simulation. You see that since it's dynamic route, it's going to know that this interface is off. What's the next? What's the next shortest route? Then it's going to pick that. Always one shortcut. We'll pick the shortest one. Now, what if router 3 is also off? That's what I was saying. What if router 3 is also off? What's going to happen? You turn router 3 off. Now there's no way it's going to get to PC4. Let's just try it. It's going to say host unreachable. Boom. Because there's no path for it to take. Everything has been turned off. So that's when we introduce another serial interface. So let me turn it off, then start with the configuration. Add another interface over here. Turn it back on. Now let me do something with other routers. Yep. Okay, everything is ready. Why is this one off? Why not turn it on? Okay. Now that everyone is fully active, let's connect them. Celebrate Jesus, celebrate. I think you will leave it like this. You know what? Let me add it. More redundancy doesn't spoil the network. Okay, so now start with configuration. So conf this pass is not really needed, but I just wanted it in case, like to show you all about redundancy. Zero 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 slash zero IP address then dot 0.4.1 two 255.255.255.252 clock rate. And probably in my next video I might explain this clock rate and something. Depends on wherever the wind blows in. Done with the IP, so we start with the router. Again, we've already set a router ID for router 1, so there's no need for us to set one. All we just need is tell it that your OSPF is 10.0.4.0.0.0.0.3 and then we have we're done router 1. Let's move to router 4. see. Two five five dot two five five dot wait, did I? Yeah, I think this one is we shut down. So we are done. Let's move to router 2. Clock rate. That's the clock rate for that. Keep forgetting. Anyway, I did do something right. We'll see it when we print something. Router OSPF 1. Router 2 down. Go to router 3. So it might be probably taking longer. Almost done. Router OSPF 1 net network 7.0.0.0.3 and we are done. We are done, guys. We are done. Now we have a truly redundant network. I think I should have just checked for the neighbors. You will see three neighbors right now. So exit, show IPOSPF neighbor. I get the spelling of neighbor wrong. And you can see we have three neighbors. Hooray! Now let's ping it and get over it. So I'm going to ping. Who should I ping? I mean, let's ping PC4. Wow, look at the time. So let's just start pinging. Let's see which path to take. Obviously, take the shortest path. Take the short one. Take the short one. What the fuck? Ah, oh, yeah. Took the short one. Took the short one. So we've established the fact that OSPF always takes the shortest path. It will take the shortest path. It's no longer going to take this path or anything. We've already created the shortest path, which is this link right here. So it will take the shortest. Fuck is it going the other side? So boring. Okay, now let's paint it again. But I mean we are done with this lab. OSPF single area. I'll bring out the PDF. So we're done with this lab. I'll provide a link to this PDF. I'll just upload it on my GitHub and put the link in the description. If you want the PDF, you can pull up there and get a PDF for yourself then and perform your own labs at home. So thank you guys. I think this video has gotten long, taking longer than I expected. So yeah, thank you. And probably if you want me to work on any other lab, you can also comment on it. I mean, we grow by learning every day, so your suggestions are welcomed. And if you like, you can just like and subscribe. Thank you.